Just like we have inverse operations like adding, subtracting, multiplying, dividing, squaring, and doing the square root, we also have something called inverse functions. Inverse functions undo each other, and if I look at the graph, they're reflected over the equation y equals x. And overall what it means is that my x values have switched with my y values and vice versa. So we'll start with looking at points. So from points, literally all we're going to do is switch x and y. So I would have, for this one, the 0.52, 1, 3, and 6, 4. Then we would have 1, 2, 3, 2, and 7, 2. Negative 2, 2, 3, negative 3, and negative 4, negative 4. When we're solving for equations, what we do is switch x and y, so the same first step, but now I have an equation, so we're going to solve for that new y, then replace y with f inverse of x. And for inverse, it has this little exponent of to the negative 1. Don't ask me why. That's actually really annoying. But moving on with our life. So my first step is switch x and y. So x equals 3y minus 4. And then we're going to solve for y. So I need to add 4 to both sides. So I get x plus 4 equals 3y. Then divide by 3 on both sides. X plus 4 over 3 equals y. And since we're finding the inverse, we'll use our inverse function notation. Alright. On your copy, I changed this to a cube root. So I don't see a y right now, so we're actually going to replace f of x with y. And now we're going to solve and get switch x and y. So x equals the cube root of 3, the cube root of y minus 5. We can tell that I haven't had my tea today. Okay, cube both sides. X cubed equals y minus 5, and then add 5 to both sides. So x cubed plus 5 equals y, and replace y with our function notation. F inverse of x. All right. So this last one is going to be our most complicated example because I have an x in the numerator and denominator of a fraction. So just stay with me. We're going to replace f of x with y. So y equals 2x plus 1 over x minus 3. X equals 2y plus 1 over y minus 3. So my first step is to clear my denominator, so I'm going to multiply on both sides by y minus 3. Y minus 3. So I get x times y minus 3 equals 2y plus 1. Now what I'm going to do is distribute on the left side. So I get xy minus 3x equals 2y plus 1. And you might want to write a note to the side what this next step is to remind yourself later. We're going to move everything with y's to the left and everything that does not have a y to the right. So that means now I'm going to have x, y, and then subtract the other 2y over, so minus 2y equals 1, and I'm going to move that negative 3x and it's going to become a positive 3x. Now what do you notice with what we have on the left? On the left, we now have both terms have a y, so it's a GCF of y. When I factor out that GCF, I get x minus 2, and we still have equals 1 plus 3x. And my goal is to have y by itself on the left side, so now we're going to divide by x minus 2 on both sides. Y equals 1 plus 3x over x minus 2. And I ran out of room. Maybe you ran out of room too. So I'm going to just cross that out and put f inverse of x since I have no room. So that was the hardest one. If you can do that, we're going to be awesome. All right. So the next part is to see whether two things are in fact inverses or not. Now, I know what you want to do. What you want to do is find the inverse of f of x and tell me, oh, look, it's g of x. They're inverses. Okay, we can't do that. I know. So what we want to do is we're going to find f of g of x. We're also going to find g of f of x. And if they're inverses, then that means both of them should reduce to x. And if one of them doesn't, then we can just stop. We don't need to find the second one. Okay? So when I ask you this on a test, you have to show me the f of g of x and the g of f of x. You can't just find the inverse of one and tell me, oh, look, it's the other one. Yay. I know. Okay, so if I want to do f of g of x, we're going to do that one first. That means, remember from last class, we're going to plug in g of x into f of x. So 2 times g of x is x plus 2 over 2 minus 4. So when I do that, the 2 and the 2 cancel. So I have x plus 2 minus 4, which gives me x minus 2. So I didn't reduce to x, so these are not inverses. Once again, if they don't work, you just move on with your life. You don't need to worry about the other one. Okay, yours says cubed and then cube root. I have an old copy and it was squared and square root. And there's a reason I changed it, which you don't need to care about. F of g of x means we're going to plug in g to f of x. So we are cubing something and minusing 3. And what we're cubing is the cube root of x plus 3. And I know you can just look at this and see it's going to work, but show you work. So when I cube and cube root, I'm just going to get x plus 3. And x plus 3 minus 3 just reduces to x. So that one works. And now we're going to go the other way. G of f of x. So the cube root of something plus 3. And that something is x cubed minus 3. So the first thing that's going to cancel here is the minus 3 plus 3. So I get the cube root of x cubed, which is just x. So yes, they are inverses. All right, last one. F of g of x. And remember there's that other way to write a composition. F kind of looks like fog, but it's not fog. You know what I mean? Okay, negative 1/3 blah plus 3. And in this problem, that blah is negative 3x plus 9. So we have to do some distribution here. We get negative 1/3 times negative 3 is positive x, minus 3 plus 3. Not every problem involves all these 3's, but that's what we got in this one. G of f of x, negative 3 blah plus 9. And my blah I'm plugging in totally did not leave enough room. Look at how tiny I'm writing. Impressive. Okay. I'm proud of myself, y'all. Alright, so we get 1x minus 9 plus 9, which does give me x. So yes, these are inverses. The last section, I just feel like it confuses everyone, but it's actually the simplest thing. Are you ready? Okay, so what is the definition of f of x and the inverse? It undoes each other. So in one of these problems, if I'm doing f of f inverse, I'm just left with whatever it is I plug in, whether that's x. I can change the order. I can do f inverse of f gives me x. This time I have a number, so f of f inverse is just what I'm plugging in, which is 3. F inverse of f of 14 pi. Doesn't matter that 14 pi looks all crazy. Yeah. All right. And look, I kind of skipped this part. I gave you this like really crazy equation. So you know what some people do? Some people try to find the inverse of this and then they cry and all of that. But it doesn't matter what we start with. F and F inverse or G and G inverse, they undo each other.